here we have the example 5 question, which was for homework. Now we have to draw the forces in the force diagram. Now at A, we're going to consider the normal contact force to be vertical and the friction to be horizontal. The reason we're doing this is because the plank here, the corner of the plank, acts like a particle on the surface of the ground. So the normal contact force and the friction are always perpendicular to the plane and parallel to the plane. And since the corner of the plank is acting as the particle, the plane is the ground. So it's got to be normal to the ground and parallel to the ground. The weight acts at the centre of mass of the plank, which is uniform, so it acts halfway up. And then here, the normal contact force is going to be perpendicular to the slope. Since the slope is acting like a surface here, and the corner of the marble is acting like something sliding on a surface. So the normal contact force there is perpendicular to the slope. Now this is different from what I wrote down in class because I think I was just rushing, but that's what the diagram should look like. The first thing to do is to take moments about A. Taking moments about A, well, we'll take the perpendicular component of the weight, and since this is alpha, I'm going to draw alpha, a nice triangle for alpha, and say that, well, we know that the height is 0.7, the width is 2.4, and the hypotenuse is 2.5 when you do Pythagoras. This is going to be useful. So I can say that for the moment about A, considering the weight, it's the perpendicular component that has a moment, so it's 200 cos alpha times by the distance 1.75. And then this is going to be equal to r of x times by 2.5. Okay. We know if I write 2.5 times r of x on the left, I'll change that in a second, this is going to be equal to 200 times by cos alpha, looking at the triangle, is 2.4 over 2.5. So we can replace cos alpha by 2.4 over 2.5. Okay. Now to find r of x, you chuck this in your calculator, divide by 2.5, and you get r of x is 134.4. Nice. Now all we need to do is find r of A and the friction of A. So we're going to resolve vertically and horizontally to do that. Vertically, we have r of A acting up. We have the component r of x acting up as well, which is going to be r of x times cos of alpha. And this is equal to 200, since everything's in equilibrium. So, replacing r of x by 134.4 and replacing cos alpha by 2.4 over 2.5. When you solve this equation, you get r of A is equal to 71.0 to 3 significant figures. Obviously, you would write 3SF, and you wouldn't use 71 in your calculator, you would use the actual number. Resolving horizontally gives friction of A is equal to the component r of x acting horizontally, which is r of x sine alpha, which is 134.4 times by 0.7 over 2.5 from the triangle in purple. When you do this, you get 36.6 newtons to 3 significant figures. So mu is just the friction of A divided by r of A, and when you do this, you get 0.530 to 3 significant figures. So that was how to do the example 5, which was a homework question. You only had to do 3 things. You had to consider the moments about A, you had to consider horizontal and vertical forces. I suppose the difficulty in this question was drawing the force diagram correctly.